So, in preparation for the bullet lab that we're going to be doing today and tomorrow, we've got to review the concept of molarity. So, who remembers what molarity is? Concentration, moles per liter. Now that you guys are big kids, big boys and girls, molarity is, I'm actually on the wrong page to start out with. That's an awesome way to start. There we go. Molarity is going to be with units of moles per liter. Big M, no longer going to be an acceptable unit for me. If something's 5 molar, I want you to write 5 moles per liter. You could write it like this. You can write it like this. Okay, lots of ways you can do it. All right? So really quick, we're going to go ahead and calculate the molarity of a solution of sodium chloride in 1 liter if we have 0.875 moles in it. And then we're going to just change our volumes and calculate all the different molarities. So what would the molarity be if we had 0.875 moles? If you put this in your calculator, I'm worried. What would be the molarity? 0.875. Someone say 1. Thought I just heard 1. I'm a little worried. And I heard that you spit at me. Yes, in a problem. So apparently, no. Kinsey, in a physics problem, spit a spitball at me. So I already informed them that I need to get my revenge. So in a future problem, I will be doing something to you as well. We've discussed it, but I'm going to leave it for a surprise. All right, this is 0.875 moles per liter. I'm going to make all of these 3 sig figs because I hate 1 sig fig. So making all of those 3. All right, what would the molarity be if we had 0.875 mils? Okay, I don't need to see the conversion from mils to liters, but you do need to write down how many liters. How many liters is 500 mils? 0.5. All right, so what's that? 1.75. Thank you, 1.75. All right, and then we have a molarity of 0.875 divided by 0.100. So what is that? That's a high molarity. And lastly, if we have a molarity of 0.875 over 6 liters, we get 0.146. So that's pretty easy, right? What's different this year for you guys is your need to actually make up your own solutions yourself, okay? So what you're going to do usually is use some sort of precise or accurate, I should say, vessel for measuring out total volumes of solution. So if you look at this picture here, these are things called volumetric flasks. You're going to be responsible for making solutions from solids and solutions where you're diluting a really concentrated stock to a certain particular concentration depending upon what you need. So these volumetric flasks only measure 1 volume. For instance, this is a 2-liter volumetric. What you would do is put your necessary either stock solution or solid into that, and then you'd fill it to the mark. That is the 2-liter mark, so you know you have exactly 2 liters of solution. Because in moles per liter, the liter here is liters of solution. It is not liters of solvent. It's not liters of just the water. It's of the entire solution. Okay, so we need to know exactly how much solution we've made. So this would be like a 1 liter, and this is a 500, and this is a 250 mil. Okay, you guys are going to be using tomorrow in the bullet lab little bitty 100 mil flasks, which are more expensive, Butterfingers, than graduated cylinders. Why are they more expensive? Because they measure out, technically I believe it's to the thousands, like it's actually 100.000 mils. So we're going to treat those nice and carefully tomorrow. No dropping. You've got that. Yesterday didn't count. You couldn't break anything yesterday. It has to be 3 labs with breakable things before I release you from Butterfinger status. All right. Are y'all good? So I'm going to talk about exactly when I ask you how to prepare a solution, what I expect. So in these problems right here, this is the example first off of diluting not diluting, but dissolving a solid to get a certain concentration. I do this all the time. All my solutions that I make for you guys are either from other solids or they're from concentrated liquids. To make 500 mils of a 0.05 molar solution of copper nitrate, I go into my stockroom, grab the copper nitrate solid from the shelf, and then I just do it. So what do I do? What do I have to figure out? Well, again, we know molarity is equal to moles per liter. I want to prepare a 0.0500 molar solution. I'm going to need to figure out moles. And how much do I want to make again? 0.5 liters. All right, so once I figure out moles, that'll give me how much copper 2 nitrate. And I won't be done at that point, but someone go ahead and tell me how many moles that is. 0.00250. Yeah, it must be moles of CuNO3. Now, if I were to say, hey, go make it, can I measure out 0.00250 moles in the lab? That's not very useful. What should I convert that to? Grams. So I'm going to convert it to grams. I have the molar mass here, and the molar mass is 187.67. Oops, wrong way. Bad demo. For every 1 mole, I have 187.67 grams. All right, so how many grams would I need to put into my solution? 0.469 grams of copper 2 nitrate. Now, I'd say the problem's done, but it's really not, because look what the problem says. How would you prepare? That doesn't really tell me how would I prepare. So this is my expectation. You need to tell me something similar to the following. To make the solution, I would take 0.469 grams of nitrate, copper 2 nitrate, and put it into what size flask? A 500 ml flask. Remember, from the last page, there's my 500 ml flask right here. And fill it to the line. What does filling it to the line ensure? That I have 500 mils of solution. Do I necessarily have 500 mils of water? No, because that's solid in there with it. So I'm going to, and this is what I need you to take, 0.469 grams of copper 2 nitrate, place in a 500 mil volumetric, and fill to the line. You're going to be doing this tomorrow with your bullet, with your dissolved bullet. Okay? We good? A fancy way to say fill to the line, if you want to look really fancy, is called QS. You can say Q and QS. Take this, put it in a flask, 500 ml flask, and QS. What that means, there's a Latin thing for that, I don't remember, but what they tend to say in English, it's quantity sufficient. Whatever. You can say I'm going to QS in the 500 ml volumetric flask, or I'm going to fill it to the line. But you got to include the volume of your total solution somewhere in that problem. All right, look at the next one. This one is a little different because we're going from a solution of 0.5 molar to 250 mils of a 0.04 molar. What did we do to this? We started out at a high concentration, went to a low. What's that called? I heard it, dilution. Aren't we making a dilution? So anytime you start with a stock is always the more concentrated solution, you're going to dilute. Who remembers the dilution equation from last year? Equals M2V2. It doesn't matter where you put your stock, but one side's going to be stock and one side's going to be your final solution, depending upon, it doesn't really matter. I always do, for some reason, stock on the left. So, and again, that's just me. So MV from my stock, I know I have a 0.500. Do I know how much stock I need? No, I'm calculating that volume. Do I need to prepare a total of 250 mils of 0.04 molar. Now, I know I didn't put them in the right spot, but you guys can figure it out. Why is it okay that I use 250 mils and not liters? We'll end up getting milliliters out on this side, and it's just a proportion. We're not solving for moles in the molarity equation where we have to use liters. Okay, so in this proportion, it's okay to use milliliters. So go ahead and tell me, how much stock would I need? 20 mils. 20 mils of stock. Okay, 20 mils of 0.5. Now here's a mistake students make all the time. In some cases, when, like in tomorrow's lab, you're doing serial dilutions, addition of volume will be okay, it'll work. But technically, you're not supposed to say, I'm going to take 20 mils of stock and 230 mils of water, because this is my final total volume. You need to use that volumetric flask again, because liquids aren't always 100% additive like that, depending upon their densities and their solubility in each other. So what you're going to say is you're going to take 20 mils of 0.5 molar copper 2 nitrate. What am I going to put it in? What kind of volumetric flask? A 250 mil volumetric, and then what am I going to do? QS or fill to the line. That way, in case they're not 100% additive, I'm not worried about it. And you're not going to get a precise, as accurate of a solution if you try to measure out 230 mils in a graduated cylinder or something. Okay, using that volumetric that is at a 250 mil solution is going to be the way to make your data the best. Okay? Questions on that? So when I ask you how to make something, I want those kinds of details. You just can't give me the volume or the mass. I'll be like, what do I do with that volume or mass? And I want details. All right, this is a good little problem. It says, determine the molarity of total ions in a solution prepared by dissolving that many grams of copper 2 chloride in enough water to make 600 mils of solution. Don't freak out when you see problems like this. First thing I want you to do is just find the molarity of the copper 2 chloride first. Then we'll deal with ions in a minute. So I know molarity is equal to moles per liter. How much do I know so far of the copper 2 chloride? What do I know for sure about this solution? What? Well, I know the grams, but is that going to help me solve? What piece of information do they give me that will help me solve for molarity? 600 mils, which is 0.6 liters. All right. So what do I need, though, to finish the molarity calc? Moles. That's where the grams comes in. I can take my grams, and for every 1 mole of this stuff, I have 136.45 grams. So how many moles? 0.3072. 0.072? 0.072 moles. All right, now how do I convert that to molarity? Divide it by 0.6. So what is my molarity of copper 2 chloride? Louder? 0.12. Can you give me one more sig fig? 0? Moles per liter of copper 2 chloride. Now I can ask you the question about the ions. How many ions does copper 2 chloride dissociate into? 2? 3. 1 copper 2, and then 2 of these, right? So if this is the molarity of just that, what would the molarity of those be? Total. If I have a mole of cars, how many moles of tires do I have? 4. If I have a mole of this, how many moles of ions do I have? 3. So what do? Multiply the molarity times 3. So 0.120 times 3. So my total ions is 0.360 moles per liter of total ions. Now there's a second part of the question that'll be easy now. What's the molarity of just the chloride ions? We're going to only multiply it by 2, right? Because there's only 2 chloride ions in our solution. So we get a 0.240 moles per liter of chloride. Good? All right, so now we're going to talk about the bullet lab. I'm going to get you guys with partners in a little bit, and the first thing you guys have to do is weigh your bullet casing. The point of the lab tomorrow is for you to figure out the percent of copper in the bullet, and then using a manufacturer's list, we can figure out, based on that percent, who manufactured your bullet. So what you're going to do is weigh the bullet and then do this particular calculation. I'm using different numbers, but this is a really important calculation that you need to do before tomorrow. Because tomorrow the first thing we're going to do is dissolve that bullet in nitric acid. It is a super cool reaction. But I'm not going to be wasteful and waste a whole bunch of nitric acid. So I want to know how much nitric acid is necessary to react with the copper in your bullet. So we're basically pretending your bullet is 100% copper by doing this. And then we're going to calculate through stoichiometry how much nitric acid we need. And then you're going to add a couple mils to that. And then you're going to come to me, and if you have Miss Rozier, you're going to go to Miss Rozier and say, hey, I need 5 mils of nitric acid on this bullet. And I'll do that. Whatever you tell me, I'm going to put on the bullet. Okay? So let's start with this problem. Once you know how to do this, I'll talk more about the procedure tomorrow. It says how much. So we're looking for volume of nitric acid because it's liquid. I know it's 16 molar. So what do I know? 16 moles per liter. That's all I know about this. I want to know how much is required to react. Let's pretend this is a really tiny bullet. Your bullets are much bigger than this. 0.345 grams of copper. So you have to do some stoichiometry. So what do I want to start with in stoichiometry? Which one? Yeah, my copper. My copper then can get me, I'm going to convert that to what? This is 345 grams. I can't get on the mole bridge unless I'm in moles. So for every 1 mole of copper I have 63.55 grams of copper. Awesome. Now I'm in copper moles. How do I get to nitric acid from here? Correct. 1 mole of copper, there are 4 moles. Am I going to go on? What is this going to do for me? Oops, I did 2 H's on nitric. That's awesome. So like some of y'all did on the test. I'm just kidding. You didn't. All right, HNO3. If I stop at moles, what does that do for me? Don't I know the molarity? If I know the molarity and I know moles, what can I figure out? Liters. Exactly. So go ahead and tell me how many moles of nitric acid. 0.0220. 0.0217 moles. All right, 0.0217 moles. I can then solve for liters of nitric acid. So if I know it's 16 molar, in your lab it's like 15.6 or something. I was just doing this to demonstrate the process. So just read the question in the lab when you get to it. And what do you get for liters? 196? 136. Okay, is that a useful number the way it is right now? In the lab, what do I probably want it in? Milliliters to make it easier. So that's 1.36. Watch those decimals, 1.36 mils. So in the lab, it instructs you to add 2 mils to that. So that's about 3.36. Go ahead and round to the next mil. So you'd say, I need about 4 mils, Demo, and I'll put that in there. And that's going to ensure your entire bullet will react And anything that's copper is going to be dissolved into solution. Okay? So that's part one of what you're not dissolving today, but you and your partner need to get this calc done before tomorrow. You have to actually do the whole pre-lab tomorrow. It would be a good idea to do that with your partner before you go. Another really important thing that you have to do today is do some dilutions. Let me go ahead and go back. I'm going to extend this page some if I can. Yes, I can. Okay, so what's the deal with the lab tomorrow? So you're going to dissolve your bullet in nitric acid. Bloop. Okay? And so you're going to have your copper +2. And then we're going to basically run this whole lab with a colorimeter, doing spectrophotometry. Anyone know why we can do spectrophotometry on copper 2 solutions? It's not blue, it's colored. Okay? So if you have a solution that's colored and you run light through it, the darker it gets, the more and more light is absorbed, correct? Okay. So what you're going to do first is create something called a standard curve. I'm going to give you a solution that is 0.4 molar in copper +2. Part of your job today is to make 4 dilutions from this amount. Okay, it tells you in the lab, I believe, to make sure these 4 dilutions fall between, I think, I might be wrong, between 0.25 to 0.025. So your 4 dilutions have to fall between those molarities. So how do you do this? Well, in the problem where you do this, I think it's number 2 or 3 in the pre-lab, you need to make your final solution, you need to make 10 mils of it. So if I start with 0.4 molar stock, what volume do I need to make? Pick something within that range. Pick something. 0.2? Well, yeah, that's an easy one. Pick a weird number. I want to show you something. 0.17? 0.17. Say you're picking that times, you're going to choose a total volume of 10 in all your dilutions. I want all of you to make 10 mils in all your dilutions. You need that much to test, okay? So someone do the math here. What is this? Okay, so to get 0.17, I would have to take 4.25 mils of this. So here's the trick. You're going to need to do this on scratch paper to find out exactly what dilutions you want to use. This is a tough thing to measure out, okay? I don't care if this is an even number or not. Your concentrations, you're going to be typing into your LabQuest. You can type 4.725. You can type numbers like crazy. What's going to be important is for you to make volumes that you can easily pipette. So I would try to, like, instead of using 4.25, go ahead and plug a 4 in there now that you know what that is and solve for what this concentration would be then. I would like, if possible, your pipetting to be even, or 0.5s are fine. You can pipette that pretty easily. Does that make sense at all? Okay? And you just have to do 4 different concentrations that are spread throughout this range. The more spread out, the better your standard curve will be. So what is this standard curve business I'm talking about? You guys are going to be testing the absorbance of all 5 of your solutions, the 0.4 and the stock and your 4 dilutions. So by doing the standard curve, you're plotting the concentration of these guys on the x-axis and the absorbance on the y-axis. All right? And so as concentration increases, absorbance increases. So you'll probably get something like that. Hopefully it'll be straighter than that. And what's that thing you do to find the best fit line? What was that called? You're going to run linear regression. If you've never done it, you need to come talk to me because it's part of the pre-lab tonight. You're going to run linear regression on some sample data. You're going to run linear regression and you're going to get the formula for this line. Okay? Then you're going to go and you're going to take your bullet solution. You're going to put your bullet solution and you're going to have put it in a 100 ml volumetric and QS'd it to 100 mils, you're going to take some of that solution and test its absorbance. And you're going to use your standard curve. If I find out my bullet has an absorbance of about that, what value is that in my formula? My Y. So all I have to do is solve for X, and that'll give me the concentration of copper in my bullet. Once I know concentration, I'm scoring because I QS'd it to 100. If I know concentration and I know volume, what can I figure out? No, I know molarity. I know concentration. I know volume. What can I figure out? Moles. I convert moles to grams, and then I can figure out what percent of those original grams were actually copper. It's kind of sexy. All right? So, your job today, weigh your bullet. You're also supposed to record the writing at the bottom of the bullet, okay? You got to get that done with your partner. And what's really most important is for you to do this together and come up with your 4 dilutions, because first thing tomorrow I'm going to be like, go make your dilutions after I do the breakdown in the lab. Another thing that would be useful to get done is calculating the amount of nitric acid you need. That needs to be done by tomorrow, but if you do it separately, it's not, the number can vary a little bit. I'm not going to freak out too much about that. So that needs to get done. I would do all this on scratch paper because it's going to be in different order than what is in the pre-lab. You can do it on scratch paper and then do the pre-lab tonight. Okay, so let me call out partners.